All right, so Unit 7, Day 7 notes. There is actually going to be a part 1 and a part 2 to these notes. I'm going to start with part 1 with the equations. Part 2, I'm just going to have all of the word problems. So if you just wanted to kind of look over the word problems to try to figure out how to do those, you can skip to Unit 7, Day 7, part 2 notes. But this particular part, I'm just going to complete the equations on the front of there, the equations on the back, and then there's a couple of equations on the third page. I'm going to complete the word problems. I'm not going to complete until the second part of Day 7 notes. So when you look it up, just look up Math 9, Unit 7, Day 7, Part 1, and Math 9, Unit 7, Day 7, Part 2. Okay, notes. All right, so I am going to write this problem on a separate sheet of paper. It takes quite a while to kind of get through these because it just takes a long time. You have a lot of steps, and I am going to just go ahead and write this on a separate sheet of paper. This is really not enough space to kind of complete these problems. So 5 plus 4 over v minus 1 equals negative, and then 4 v minus 2, and then v minus 1. All right. These problems, or this problem right here, is very similar to where we ended in Day 6 notes. So if you're having problems with this, you probably should go back to Day 6 and kind of look over those notes. These problems right here, you'll have to find the LCD, least common denominator, which in this case is v minus 1, because there's 1 in both, and then v minus 2. So v minus 1 and v minus 2. And if you're having a problem with those and you're struggling with those, go back to the Day 6 notes, because that's when we really kind of went over and broke that down. So now you're going to multiply this by every single term. We have 3 terms. So you'll multiply this by the 5. So 5 times v minus 1, v minus 2, okay? This times this, as you see, the v minus 1s will cancel out, but what's left over is the 4 and then the v minus 2, okay? Equals, and of course this negative goes with the number of tops, so negative 4, and then look, v minus 1 cancels out, v minus 2 cancel out. So you're just gonna have negative 4 left over there, okay? Here we're going to FOIL it, but I would just go ahead and distribute that 5 to both first. 5v minus 5, and then v minus 2. Let's go ahead and FOIL that. 5v times v is 5v squared. 5v times negative 2 is negative 10v. Negative 5 times v, negative 5v, and negative 5 times negative 2 is positive 10. Okay, combine like terms in the middle there. 5v squared and negative 10, negative 5 become negative 15v plus 10. Now we can bring this one down, multiplying the 4 times the v and then 4 times the negative 2. This becomes positive 4v minus 8, all equal to negative 4, okay? So there is a lot of steps there. So make sure you're taking your time, okay? Combine like terms, negative 15v, positive 4v, and it looks like 10 and negative 8. So it becomes 5v squared, negative 15, and positive 4 is negative 11v, and then positive 10, negative 8 plus 2 equals negative 4. And when you're having the squared value there, you have to have everything equal to 0. So I'm going to add 4 to both sides, and we will get 5v squared minus 11v plus 6 equals 0. Okay, so we aren't done there, but at least we've gotten ourselves to a point where we have the square value, everything's equal to 0. Now we can factor it. Okay, circle, slide, divide. This becomes v squared minus 11v plus 30 equals 0. Same or different? This looks like same. Last number's positive, so it's going to be, they're both going to be a negative. So this is going to be V minus and V minus. Multiples of 30 that add to give you 11 looks like 5 and 6. Don't forget to divide by that number here. So this doesn't simplify, so it becomes 5V minus 6. This does simplify, that becomes V minus 1, and that equals to 0. Now, I do want to say something before I go ahead and solve this, and I probably should have said something at first. Before you even start these problems, what you have to realize here is that there are some numbers that cannot be the answer, okay? So there are some numbers that you have to exclude. And what are they? Because we've talked about that as well. V cannot be equal to 1. Why? Because it will make it 0 right here, okay? It'll make it 0 right there. So you know you cannot have 0 at the bottom of a fraction. Same thing, B can also not be equal to positive 2. Why? Because it'll be 0 there at the bottom of a fraction. But so before you even start, you have to give some parameters as to what B cannot be equal to. And then if you get one of those answers, you know that can't be an answer because it cannot happen within our problem. So in this case, I say that because I see this B minus 1, and so you'll have 5B minus 6 equals 0 also, and B minus 1 equals 0. So I'll solve this one out, add 6, 5B equals 6, divide by 5, B is equal to 6 over 5, okay? So that's one of our solutions. Here, if I add 1, B is also equal to 1. But as we set up here at the beginning, B cannot equal to positive 1 because it'll make it 0. So when you get down to your answers, 1 cannot be a solution. Your only solution is B equals 6 over 5, okay? 1 will make this equal to 0, and that cannot happen. And we've talked about this before. If you don't remember, go ahead and go back to a couple of days. I think it was day 3 or day 2. Unit 7, we have talked about exclusions, okay, where it cannot equal. All right, good. So let's move on to the next problem we have here, okay? And we will have, and I'm going to flip this paper over, I'm going to have to write it down here. All right, so in this problem we have, again, let's talk about exclusions first. U cannot equal to what? Looks like positive 2, okay? U also cannot equal to positive 5. Both of those numbers will make U 0 at the bottom. So that is not something that you can have it equal to. Once we get to the problem, we might not have U 2 or 5 as a solution, which is fine. But if we do have them, we have to say, no, that cannot be a solution. All right, so let's start. I'm going to write down negative, then you have 5, and then U minus 2 and U minus 5 equals negative 3 plus 5 over U minus 5, okay? And again, we will solve this the same way we solved the first problem, which is basically going in and finding the common denominator. U equals U minus 2 and U minus 5 is our common denominator there. Let's go ahead and multiply these two by this term. And again, the U minus 2 cancels out, U minus 5 cancels out. We'll be left with negative 5 there. Negative 5 equals, then you're multiplying this number by the negative 3. So negative 3 times U minus 5, and then U minus 2. And then here you see the U minus 5 cancels out. This becomes plus 5 parentheses U minus 2. Okay. Same kind of concept that we did last time, where you're going to have to basically distribute this first. That becomes negative 3U plus 15. And you're going to multiply that one by U minus 2. FOIL it. Negative 3 times U becomes negative 3U squared. Multiply this by this. That becomes I'm sorry, negative 3u squared, and then it becomes, you're multiplying there, it becomes positive 6u. 15 times u is positive 15u. And then 15 times negative 2 is negative 30. Okay, combine like terms there. And it becomes negative 5 equals negative 3u squared. And I'm going to add those two. That looks like it's positive 21u minus 30. Okay, I do not like this negative right here. If I have that negative right there, I want to make that positive. I'm going to bring every single thing to that side because I want that first number to be positive. So I'm going to add 3u to both sides and subtract 21u and add 30. So I'm going to get it so that it's equal to 0. We already know when it has a squared value, everything, sorry, this is squared, everything has to be equal to 0. So once I bring everything over here, it will be equal to 0. So now it becomes plus 3u squared, of course, minus 21u, and then that plus 30 is going to be under the 5. So now it will be equal to 0. That's exactly what we want it to be. And it will be 3u squared minus 21u plus, looks like 25, okay? Because we have 30 minus 5. So that's our situation there. Let's see if we can kind of find something that goes here. Same, so we're going to say u squared minus 21u, and then I'll have 3 times 25, 75 probably. 25 times 3 is 75. And we're trying to find multiples, and of course that's a plus, so you know it's going to be the same. Both of them look like they're going to be negative. Okay, multiples of 75 that add to give you 25. Can we find one? I'll try 5 first. I always like to try 5. And 5, and it's basically 75 divided by 5 is 15. Which is 15 plus 5. That is not going to give you the answer. Try 3. That's not going to give you the answer. Because it's 25 times 3 is 75. We already did that. I'm not sure what that would be. Let's see if I did all the math correctly. Let me look back really quickly. All right, so I'm not, okay, this is my issue here. I didn't bring this down. I would delete this video and then start all over and do it again, but I think that it's important that we make some mistakes and then go back up and try to fix those mistakes to try to figure out what did we do. So in this case, do you see how I got this answer here for my foiling situation? I got it here, but when what I didn't do is add this portion to it. This portion is missing. I didn't bring that down. So what I'm going to do is I'll get rid of this bottom part because I'm not there yet. Okay, I still have some work to do up here. So let's look here. So now when I combine these like terms, this negative 5 here and negative 3u squared plus 6u plus 15u minus 30, what I didn't do is bring this down. Plus 5u minus 10. Okay, so this part has to come down. All right, and that's where my mistake was. It is important to go back and be able to look through some of these mistakes that you make, and I make them all the time, which I like. I don't want you to think that every single thing that I do is perfect. There are so many mistakes that I make, but I have to go back and pay attention and look back to see what I did, where I missed the negative. We're all human and we all make mistakes. So I think that's important for me to show you guys that I do make mistakes at times. And I would love for you to say, hey, Miss Cannon, I think you missed a negative there. Or Miss Cannon, you were doing this problem, but I think you didn't do this right. And I will definitely go back. I don't mind saying I made a mistake. Okay, so I did there. But now that we're here, we can combine like terms. We have the 6u. and the 15, and then what was missing was this extra 5, and then the negative 30 and the negative 10 was missing. So now we have negative 5 equals negative 3u squared, okay? And we have 15 and 6 we said was 21, but now we have 22, 23, 24, 25, 26, 26u. Okay, and then negative 30, negative 10, negative 40. Whew. This is where we are. Now we're going to add the 3u squared, the negative 26u, and then add 40. Okay, so we're going to do that to both sides. Negative 26u and positive 40. Good. Now, again, we want them to be equal to 0, which they are now. This becomes 3u squared minus 26u plus 35. Okay, good. So we're going to multiply 3 times 35, and this becomes u squared minus 26u plus, and 35 times 3 becomes 105. Okay, so I'm going to try to figure it out. Maybe I'll divide by 5. Yep, 5 worked. See? Yay, same. Both of them are negative, so it's going to be u minus, and of course u minus, and we're going to use 5 and 21. I divided by 5, I got 21. 21 plus 5 is 26. Divide that by 3, divide that by 3. Doesn't simplify there. This becomes 3u minus 5 and u minus 7. Okay, that is there. So then we are going to set 3u minus 5 equals 0 and u minus 7 equals 0. Add 5. Okay, close up. 3u equals 5, divide by 3. So our u value is 5 over 3. And then we have to add 7 here. Our other solution is 7. Now, let's make sure by looking up at the top, what are our restrictions? We have u cannot equal 2, u cannot equal positive 5. Neither one of these are 2 or positive 5. So these are our answers. Okay, this and this. It wanted you to kind of separate them by commas. I'll put the 5 to 3 first. I like to put it in order and 7. Okay, those are answers. Whew, that is a lot of work, and you see how easily you could miss something and get the wrong answer after doing all of that work. So make sure you're paying attention. Kind of like how when we got to a certain point, it just didn't work out for us. I would like to sometimes like not get to that point, but it's okay. Sometimes you do have to go back and pay attention to what you're doing. All right, let's try it one more time. Here, it looks like u plus 2 over u plus 1 equals u plus 3 over u minus 3. Where are our restrictions there? Okay, where are our restrictions? Our restrictions, it looks like u cannot equal negative 1. Okay, and u cannot equal positive 3. So because negative 1 right there will make it 0, positive 3 right there will make it 0. So these are our restrictions, exclusions. We cannot have that situation. So if we have that as one of our answers, it can't. If it is, we have to mark it out. It is not a solution. All right, so let's follow the same rules. We are multiplying by the common denominator, LCD, which is u plus 1 and u minus 3. So if we multiply it there, the u plus 1s cancel out. We will have left, it looks like u plus 2 and u minus 3 is left over, plus it looks like we're just multiplying 1 times u plus 1 and u minus 3. Okay, 1 times that. I guess we don't really have to show the 1. I mean, you can if you wanted to, if you feel comfortable doing that. And this one, the u minus 3s will cancel out, but then we still have u plus 3 and u plus 1. Okay. All right, so this is a lot of foiling. So this becomes now u squared minus, now there is a portion here where you don't even have to do that middle one. You can kind of look at it and do it. I mean, personally, I can just look at it and do it, but it's fine if you have to do the whole steps. Minus 3u plus 2u minus 6. Same thing here, plus u squared minus 3u plus u minus 3 equals, and then u squared plus u plus 3u plus 3. Okay. For this one, they're all on the same side. I can just combine all the like terms. U squared plus u squared becomes 2u squared. Okay. Negative 3u, positive 2u, and then negative 3u, and then positive 1u. So that becomes like negative 1u, and this is negative 4u, and then negative 3u. Okay, so this one would be, yeah, I would like to go on my calculator just so I'm not messing that up. So I'm just going to say negative 3 plus 2 minus negative 3 plus 2 minus 3 plus 1. And that will give me my answer. Negative 3, just like you said. Negative 3u, and then 6, negative 6 and negative 3 are negative 9, is negative 9. And on this side, I'm going to combine these two for u, so this becomes u squared plus 4u plus 3. Of course, we want that equal to 0, so we're going to have to subtract u squared minus 4u minus 3, negative u squared minus 4u minus 3. Okay, that will make it so that it's equal to 0. This now becomes u squared minus 7u minus 12. Okay, same or different here? Looks like different, but can we do that? So can we simplify that there? So with that one, it's going to be 9, 10, 11, 12. And multiples of 12 that subtract, because it's different, they have to subtract to give you 7. I don't think there is one. Let me look back and make sure I'm doing that correctly. All right, so when I look back, this is written down incorrectly. So if you look at the original problem here, that's a -1, and that is a +1. I'm giving you guys a lesson on writing something down wrong, and now the whole problem is wrong. That is not uncommon, but oh my gosh, it is such a mess when you do that. So now this entire problem is not correct, and I will have to do it all again. All right, so, but it gives you that lesson that if you write it down wrong, you are not going to be able to get the correct answer. And because you guys are working in ALEKS and your tester in ALEKS, that is absolutely possible. Okay, so please show your work, and if you get it wrong or right, you know, I can show you or tell you where or what happened there. And in that case, the whole issue is that I wrote it down incorrectly. So this whole problem was done for naught, I guess. All right, so now we're going to try it again. Our exclusions are u cannot equal 1 and u cannot equal 3, positive 3. Okay, I have to say that first so that just in case one of our answers is that. So our LCD is u -1 and u -3. So let's do that again. U -1 cancels out. This becomes u +2 and u -3. Plus, of course, multiplying 1 times that becomes just u -1 and u -3. And then here, the u -3 cancels out. This becomes u +3 and u -1. Okay. Now FOIL it. U squared, okay, -3u, and then +2u -6, plus this is u squared minus 3u minus u plus 3. This one's u squared minus u plus 3u minus 3. Okay? Combine like terms, you'll have u squared and u squared. That becomes 2u squared. You'll have negative 3u and 2, negative 3u and negative u. Okay? So in your calculator, you'll put in negative 3 and then plus 2, minus 3, and minus 1. Negative 5. Negative 5u. And then, of course, negative 6 and positive 3 become negative 3. And then combine like terms there, u squared. And combine those two, that becomes positive 2u minus 3. Okay? Now we're getting rid of all of the numbers on this side. Negative u squared minus 2u plus 3. This now becomes u squared minus 7u. And as you see, those cancel out, equals 0. So when you have a problem like this, you don't really have to factor it. You see that the u's are common. Bring that u out, and this will become u minus 7. So your two solutions here are u equals 0 and u minus 7 equals 0. So positive 7 is actually also a solution. So 0 looks like u is equal to 0 and 7. Those are your solutions. Are there any restrictions? Nope. Between 0 and 7? Nope. There are only restrictions 1 and 3, so those are your solutions. Okay? So finally, after all of this, we got through this whole page of paper. But we got through it eventually. All right, so let's go to the back here. I will actually write on the paper less problems with this, less problems with trying to transferring it incorrectly on another sheet of paper. But again, you guys are working in Alex, and a lot of times you're going to have to write down the problems from the computer. So make sure you do it correctly. All right, so let's factor that. W over W plus 3 plus 9 over W plus 5 equals W minus 13 over, I'm going to say same. Both of them are positive. This is going to be W plus 5, W plus 3. All right. So what's your LCD? W plus 3 and W plus 5. Okay. So when you multiply this times the W plus 3 cancel out, W times W plus 5 plus the W plus 5 cancels out here, 9 times W plus 3. Both of those cancel out, so what's left over here is W minus 13. Okay? Distribute. This becomes W squared plus 5W plus 9W plus 3 equals W minus 13. So this one's not even as crazy as the one we just did. Combine like terms here. This is W squared plus 14W plus 3 equals W minus 13. Again, we want it to be equal to 0. So we're canceling that out so that it's equal to 0. This now becomes W squared plus 13W plus 16. Right? All right, that's what I got there. Let's see if that works out or why that doesn't. Let me look back really quickly to make sure I'm doing it correctly. All right, so I think I'm just having a rough day today, but yeah, I have to push through. My problem here is that I did not multiply 9 times 3. So I brought 3 down, but I multiplied 9 times W, but not 9 times 3. That's 27 here. Okay, sorry guys. I'm just having a rough day, I think, but I'm going to push through and do the best that I can so that hopefully I can help you, and hopefully you see that every day is not a great day in math. in the math world, but we still push through. All right, so W squared plus 14W plus 27 equals W minus 13. I'll add 13, subtract W, add 13 here. This now becomes 40 plus what, 13 W, and then W squared is there. 40 multiples of 40 that add to give you 13. 7, 8, 9, 10, 11, 12. No. Oh, that's 8, 9, 10, 11, 12, 13. Yes, 8 and 5. So W plus 5 and W plus 8. Okay. So your answer here would be W plus 5 equals 0. W plus 8 equals 0. Subtract 8. W is going to be equal to 8. Subtract 5 from here. W is also equal to -5. We need to see the restrictions to make sure. Looks like W cannot be -5 and W cannot be -3 there. Okay. So in this case, it says W is -5. That is not true. Can't be true. W 8 is our solution, our only solution. Cannot be 5. Okay. So again, I'm sorry about that mistake that I made again. I could honestly do this video again, but I'm not going to. I think that mistakes are important, and working through them are important. So I'm having a rough day today, but I have not always had wonderful, easy days in mathematics. I have had a lot of tears, I'll tell you that much. But I overcame, and you too can overcome. All right, so how would I solve this problem if I'm solving for A? I would put this over 1, okay? I'd make it like this, F over A equals P over 1, and I'd cross multiply. Cross multiply, cross multiply. So this now becomes F times 1 is F, A times P. And then for A, getting A by itself is your purpose. So my answer here would be A equals F over P. Once you get A by alone, you know that you're done and you solve the problem. So here, let's get Y alone. Okay, so I'm going to do the same thing I just did. Put this over 1. So it's going to be X plus 6, and then Y plus Z equals W over 1. I'll cross multiply. W times Y plus Z equals 1 times X plus 6 is just X plus 6. And I'm solving for Y. I will not distribute. Not distribute. I would just divide away that W. Okay. So now it becomes, if I had this on another sheet of paper, I don't have enough space. This becomes Y plus Z, because I got rid of the W there, and then it equals to X plus 6 over W. Okay. And then with that particular one, because we're solving for Y, I'm getting rid of Z, subtract Z. Okay. So what it looks like is Y equals X plus 6 over W minus Z. That's your answer. It is not a pretty one, but that is how you would solve that problem. Okay. All right, so the next one, again, let me just put it on a sheet of paper. And being very careful and vigilant that I'm going to write it correctly. This one is L over P times R plus S equals N. I'm solving for R. Okay, I think was that correctly? Good. We're solving for R. So same situation here. I put this over 1, cross multiply. We have Pn together on the outside because I multiply P times N, and then R plus S there. Okay, still. So multiplying this times this, and R plus S is still there. L times 1 is just L. Okay, and again, I'm solving for R. So now I'm just going to divide away Pn. I'm not going to distribute. It cancels out there. This becomes R plus S equals L over Pn. And then I'm getting R by itself, so I have to subtract S. So this is R equals L over Pn minus S. And you are done when R is by itself. Okay. Good. Next problem looks like this. Okay. And again, I would have, let me write that out so I can have enough room. 5 equals S over R1 plus S over R2. Okay, and I'm trying to get R1, solve for R1. Okay, that is my purpose. Now, with this particular problem, because it's not a proportion, you can't cross multiply, you would do this how we've been doing it, where you have to have the common denominator. And our common denominator looks like R1, R2. Okay, R1, R2 is our common denominator. So I'm going to multiply that first by 5. So 5 times R1, R2. Then looks like that cancels out there. The R1s cancel out. So it becomes equals S. That's an S, not a 5. It's so great that they had this make this a 5 and an S, so they're so similar. But anyway, S R2. And this one plus, again, the R2 cancels out here, and this one's S R1. Okay. And please remember what we're trying to do is get the R1s by itself. Okay. So you see how this has an R1 and this has an R1? I'm going to subtract this S R1 from both sides because I need the R1s together. Okay. So this becomes S R1 negative, right? Or I just make, let me make that 5. That 5 first. There's a way that I can make this look different. But anyway, 5 R1 R2 minus S R1 equals S R2. Okay. So now both of these situations have R1 in them. I'm going to use the distributive property opposite. So instead of distributing, I'm going to take R1 out of here. Okay. If I take one out, you see how they both have R1s? I took R1 out. Now what is left over? 5 R2 is left over because I took R1 out. R1 here minus S. Okay. Equals SR2. Now I can divide away 5R2 minus S on both sides. So now that cancels out. R1 is going to be equal to SR2 over 5R2 minus S. That is not an easy problem. And I'm sure you're going to be, when you're working in ALEKS, you're going to have to be working on some problems like that. But that one is not easy. Will you see it a lot? Probably not very often, but it is something that you will see eventually. So you do need to know how to do that. Okay. All right, so let's move on to the top one here. And once we're done with this one, I'm going to stop the recording, and then I will just do the word problems on their own. Okay, so here, this one, same situation as we've been doing. We have to have the common denominator. We're solving for G. Our common denominator looks like FG. So here, it'll cancel out the F's. It becomes 7G is our what was left over. Here, the G's will cancel out. It will become plus 6F. Okay, and then here, nothing cancels out, so it's going to be HFG. And of course, since we're solving for G, we need the G's together. Okay, we need the G's together. So I'm going to subtract 6F from both sides because I need to I need that G by itself, and I'll subtract. Okay, so I'll have 7G equals HFG and then minus 6f. I just put this next to each other. I need the g's on the same side though. So at negative hfg, I guess I could have just brought that to that side. Why am I making more work for myself? So 7g minus hfg is equal to negative 6f. Okay, that's what happened there. Let me take the g's out. So g, and what's left over is 7 minus hf. Okay. And then like we did for the last one, I'm going to just divide away what I don't need. I need g by myself. So I'm going to divide 7 minus hf on both sides. So my answer here for g would equal negative 6f over 7 minus hf. This is my answer. Now that I got g by itself. Woo! Those are not easy problems, but we got through. Finally.